Moving on from 4.5 to 4.6. Some people pronounce this arithmetic sequences. I like to call them arithmetic sequences because I sound fancy when I say it that way. So you're going to hear me call them arithmetic sequences. So 4.6, arithmetic sequences. So let's first talk about what a sequence is, just a sequence in general. A sequence is an ordered list of numbers. Each number in a sequence is called a term. So we're going to be using the word sequence and the word term a lot today. Each term, a sub n, that's a subscript n. That's what that is. It's a subscript n, so I say a sub n to denote that it's a subscript. Has a specific position in the sequence. So it gives us an example down here of a sequence. We have 5, 10, 15, 20, 25. The dots after the sequence just means that the sequence is carrying on and on and on and on and on. Forever and ever and ever. Okay? So 5 is in the first position of the sequence. That would be our first term of the sequence. So we would denote it as a sub 1. 10, that'd be a sub what? 2. 15, a sub 3. 20, a sub 4. 25, a sub 5. And then a sub n is in the nth position. It's the nth term of my sequence.
Is that where umpteenth came from?
Do what?
Like for the umpteenth time?
Probably. Something like that. Does that make sense though? The subscript is just the term number of the sequence. So 5 is the first term, so it's a sub 1. 10 is the second term, so it's a sub 2. So on and so forth. Does that make sense?
Wait, so 5 would be a sub 2?
Nope. 5 is a sub 1. Sorry. I put a sub 1 down below it because it's the first position. 10 is a sub 2. 15 a sub 3. 20 a sub 4. 25 a sub 5. First term, second term, third term, fourth term, fifth term. Nth term. Any questions on that? We all right so far?
Yeah. Sure.
Can I move on?
Yeah.
Now let's talk specifically about arithmetic sequences. In an arithmetic sequence, the difference between each pair of consecutive terms is the same. This is what makes it an arithmetic sequence. This difference, we call it the common difference. Each term is found by adding the common difference to the previous term. So, the sequence that we saw on the previous slide, which is right here also, 5, 10, 15, 20, so on and so forth. It's arithmetic because we're doing what each time? Adding 5. 5 plus 5 gives me 10. 10 plus 5 gives me 15. 15 plus 5 gives me 20. And that sequence carries on forever and ever and ever. So, 5 is my common difference. We often denote the common difference with the variable d. So the common difference here would be d equals 5. Because that's what we're adding each time to get the next term. D can be a negative number. We would say we're adding a negative number each time, which in reality we're just subtracting. Adding a negative is the same thing as subtracting a number. Not too bad, right?
No.
Pretty easy.
And then it's about to get real hot.
Hopefully not too terrible. Can I go ahead and move on?
Yes. Just a second.
Okay, I'll wait a little bit. Am I good to move on now?
Yes.
First example, write the next three terms of the arithmetic sequence. So it tells me it's arithmetic. So it does have a common difference. Raise your hand. Do not shout it out. If you can tell me what the common difference is. It would be -7. We're adding -7 each time. -7 plus -7 gives me -14. -14 plus -7 gives me -21. -21 plus -7 gives me -28. So now I can use that common difference to get the next three terms. So raise your hand if you can give me the next term after -28. -28 plus -7.
-35.
-35. Raise your hand if you give me the next term after that.
-42.
-42.
-49.
-49. There's the next three terms. So we're going to put a dot, dot,
No.
dot after it to let me know that the sequence is going to keep continuing up. Okay? Not too bad? And that'd be it for this example.
But for this example.
For this example, yes. There's going to be other stuff that's not this. Any questions on example 1? Pretty easy, right? Okay, moving on. Graphing arithmetic sequences. To graph a sequence, let a term's position number in the sequence be the x value. The term a sub n is the corresponding y value. Plot the ordered pairs in, comma, a sub n. So we'll use the sequence we used on the first few slides, 5, 10, 15, 20, 25. We're going to come up with the ordered pairs for this sequence. Can anyone raise your hand and give me the first ordered pair? Nope. Not 5, 1. 1, comma 5. The x value of my ordered pair is the term number. Since 5 is my first term, that's my x value is 1. And then the actual term itself is the y value. So, knowing that, can someone raise your hand? Give me my next ordered pair. 2, 10. 10 is the second term, so the x value is 2. 10 is the actual term, so 10 is y. Can someone raise your hand and give me the third ordered pair? 3, 15. 15 is the third term, so the x value is 3. What's my fourth ordered pair? 4, comma 20. And someone raise your hand and give me my last one. Raise your hand. 5, 25. Is everyone seeing how we're getting our ordered pairs? The x value is the term number. The y value is the actual term itself. Everyone good with that? So, if I was given a graph, I could just plot those ordered pairs. Okay? So let's look at an example. Graph the arithmetic sequence 4, 8, 12, 16. Raise your hand if you can give me my first ordered pair. 1, comma 4. 4 is my first term, so the x value is 1. And I use the actual number itself for the y value. Raise your hand for the second ordered pair. 2, comma 8. Third order pairs, shout it out. 3, 12. Fourth ordered pair. 4, 16. Everyone good with that? And then these would keep going on and on and on. So I'm just going to graph those ordered pairs. Right 1 up 4. Right 2 up 8. Do my best to get 12. 3, comma 12. right there. And 4 comma 16 would be about there-ish. Does everyone see that? What do you notice about the graph of this arithmetic sequence? It's a positive slope. Okay. What else? It's in a straight line. That's what I'm looking for right there. Arithmetic sequences, when graphed, are going to always be straight lines. Can someone raise your hand and tell me why?
Because it goes up like an equal amount.
Does anyone remember what we call that?
Common difference. Yeah,
Common difference, but in terms with linear functions?
Slope.
Slope, what is another word or another phrase for slope?
Rate
Rate
of change.
of change. My arithmetic sequences have a constant rate of change, right? My term numbers are always going to go up by the same thing. 1, right? Because I'm always going to have a first term. I'm always going to have a second term, third term, fourth term. So that change in x is always going to be 1 in the denominator of my slope, right? And then for an arithmetic sequence, it always has a common difference, and it's going to be the same throughout the sequence. So my common difference will always be my slope of my line. But that's why our arithmetic sequences graph to make lines, because they have a constant rate of change. Does that make sense? So what's my rate of change here? What over what? 4 over 1. Very good. I'm rising 4, running 1 each time, right? Changing y is 4. My change in x is 1. Any questions on example 2?
No.
So arithmetic sequences will always be linear. Does everyone see that?
Yes, sir.
Moving on. All right. Does the graph represent an arithmetic sequence? Explain. So I'll let you look at it a little bit, then I'll ask for volunteers. Let it process. Does the graph represent an arithmetic sequence? Explain. Raise your hand if you're ready to answer.
Yes, it is. Because as the x value increases, the y value decreases by 3.
Very good. So I could say yes, because it has a constant rate of change. Or yes, it is a straight line. Correct?
Yes.
My slope, I'm going down 1, 2, 3, right 1. Down 1, 2, 3, right 1. 1, 2, 3, 1. So my slope / common difference is what?
Oh,
Or 3.
Not 3,
three.
negative 3.
Yeah,
It's decreasing by 3 each time. Right? So my answer would be yes, because it is a straight line, or because it has a constant rate of change, something like that.
Does that mean d equals -3?
Do what?
That the
Oh yeah, the common difference would be equal -3, because you're adding -3 each time. Yep. Questions on example 3? Not too bad?
no.
Here we go. This is some good stuff right here.
Not really.
Because consecutive terms of an arithmetic sequence have a common difference, the sequence has a constant rate of change like we just talked about. So, the points represented by any arithmetic sequence lie on a line. We also just talked about that. You can use the first term and the common difference to write a linear function that describes an arithmetic sequence. We can create a linear function for our arithmetic sequences. So they give us a little example. Let a sub 1 equal 4 and d equal 3. They're using this middle part right here. So the first term of an arithmetic sequence is a sub 1, correct? The second term is a sub 1 plus the common difference, correct? The third term is a sub 1 plus 2 times the common difference. The fourth term is a sub 1 plus 3 times the common difference. So what do we notice about what term number, and what we're multiplying by here.
It increases by 1.
It's minus 1, right? 4 minus 1 would give me 3. 3 minus 1 would give me 2. 2 minus 1 would give me 1. Right? Does everyone see that? So, it all leads up to this little formula. A sub 1 plus n minus 1 times d. So they use the numbers 4 and 3. First term is 4. The second term is 4 plus 3. Third term is 4 plus 2 times 3. Fourth term is 4 plus 3 times 3. So on and so forth. Does everyone see that? So, that leads us up to our formula for writing functions of arithmetic sequences. Let a sub n be the nth term of an arithmetic sequence with first term a sub 1 and common difference d. The nth term is given by a sub n equals, I'll write it bigger just in case you can't see it. A sub n equals a sub 1 plus n minus 1 times d. Have that written down. Write that down. Everyone needs to have that written down. Write that formula down. A sub n equals a sub 1 plus n minus 1 times d. A sub 1 is just my first term of the sequence. D is my common difference. N is the number of term I'm trying to find. So this is really beneficial if I'm asked to find like the 112th term of a sequence. Because that'd be a pain in the butt to list out 112 terms, correct? This formula helps me find the 112th term by plugging in 112 for n, solving the equation. Everyone okay with that? Can I move on?
Not yet, hold on. I gotta
Write down the equation. We good now? All right. Example 4. Write an equation for the nth term of the arithmetic sequence 14, 11, 8, 5. Then find a sub 50. So, wants me to come up with an equation first and then find the 50th term. So there's my formula, remember? So it needs an a sub 1 value. What is a sub 1?
The first term.
It's the first term in the sequence. So what's my first term in this sequence?
14.
So a sub 1 equals 14. We're not going to plug in 50 for n yet. We want to come up with the equation first. So we're going to skip over the n. The d is my common difference. What's my common difference for this specific arithmetic sequence?
Minus 3. Negative 3.
-3. We're adding -3 each time to get the next term. Does everyone see that?
Yes.
Everyone okay there?
Yes.
So I'm going to plug these values in. Everyone okay with that plug-in?
Yes.
Does anyone see anything that I can do with my -3?
Distribute.
I can distribute it, make it look a little nicer. What's n times -3?
Negative 3.
-1 times -3.
Plus 3. Or plus 3.
What's 14 plus 3? 17. Here's my equation for finding the nth term of this specific arithmetic sequence. Does everyone see that? Any questions on it? Not too bad, right? So that's the first part of what it's wanting me to do. What's the next thing it wants me to do?
For the thinking revolve.
Huh?
Solve.
Solve
The 50 and the 11.
for 50. So how do I find a sub 50?
You have to plug
Plug what in? 50 for what? N. Yep. Got to find a sub 50. So I'm replacing the n with 50. This is going to help me find the 50th term of my sequence without having to list out 50 numbers. What's negative 3 times 50?
Negative 150.
Negative 150. Negative 150 plus 17.
7.
Negative 133. Any questions on that? So the 50th term of this arithmetic sequence is negative 133. I found it without listing out all 50 terms. That's pretty nice. Questions on example 4? Not too terribly. Can I move on?
Yes.
Here we go. Another one. You can rewrite the equation for an arithmetic sequence with first term a sub 1 and common difference d in function notation by just replacing a sub n with f of n. So we take the a sub n out, replace it with f of n, and it is now in function notation.
We do the problem the same way. If it's in function.
Yeah. The domain of the function is the set of positive integers. Because if you think about it, the domain is my set of x values. My x values for any arithmetic sequence are always going to be 1, 2, 3, 4, so on and so forth, correct? So that's why the domain is the set of positive integers. They're always going to be 1 to infinity. Are there any questions on writing arithmetic sequences in function notation? Can I move on? Example 5. Here we go. Online bidding for a purse increases by $5 for each bid after the $60 initial bid. So it wants me to do 3 things here. A, write a function that represents the arithmetic sequence, so we're going to use function notation. B, graph the function. C, the winning bid is $105. How many bids were there? So we got to do 3 questions here. Letter A, write a function that represents the arithmetic sequence. So, we're just using that formula again. Except we're using the function notation version of it. So f of n instead of a sub n. Everyone good with that? So, what is the first term of my sequence? It is 60. That's the initial bid of $60. 60 is my first term. What does the bid increase by each time? $5. So is that my common difference?
Yeah.
Yes, it is. It increases by 5 each time. Any questions there? So let's plug those bad boys in to the formula. 60 plus, actually I need more room. $60 plus n minus 1 times 5. Once again, what can I do with that 5? Distribute, make it look nicer. What's n times 5? 5n. Negative 1 times 5.
Negative 5.
Negative 5. And then what is 60 minus 5? So here is my answer for letter A. That's my function that represents the given arithmetic sequence. Any questions on it?
No.
Not too bad, right? Okay, letter B says graph the function. Someone raise your hand to give me my first ordered pair.
160.
1 comma 60. Oops. Not 1 comma 6. 1 comma 60. Raise your hand if you give me my second order pair. 2 comma 65. Everyone good with that? Third order pair.
3 comma 70.
3 comma 70. And my last order pair, someone raise your hand for me.
475.
475. So I'm going to graph all these ordered pairs on my graph. If you notice, I didn't make my graph big enough, so I had to go through and make my y-axis go up by tens. So 1 comma 60. Right 1, up 60. 2 comma 65. Right 2, up 65. Three comma 70, right 3 up 70. 4 comma 75, right 4 up 75. So there would be my graphed function. Does it form a line? Bless you. Yes, it does. I know it's arithmetic. I know it's a straight line. Everyone good with that?
Yes.
So there's letter B. Letter C. The winning bid is $105. How many bids were there to get $105? So, I'm going to use this room over here. We're going to use our function f of n equals 5n plus 55. Anyone have any ideas how I could approach letter C here?
I got it. So you start at 1, like get your fingers out.
Okay.
Some like middle school or elementary school.
Okay.
Fingers out. Start at 60, 65, 70, 75, you got 80.
Okay, that would work, but that's not the most ideal option.
In verbs.
It would work. What's not? Well, how could I use my function to find the number I'm looking for?
For n, you could put 105. Or wait,
Let's think about it.
wouldn't it be like?
N is my term number, correct?
Wouldn't it be like putting it in as like f or something?
Very good. What would we treat f of n like? Which variable, x or y? Y. Remember, we treat f of x like y, so we're going to treat f of n like y. We're treating n like x. The bid numbers are my x values, my n's. My bid amounts are my y values, my f of n's. So it's giving me a price, aka one of my y values. So I need to plug 105 in for my y value, f of n. Does that make sense? And it asks me to find the number of bids that there were. So it's asking me to find the bid number, which is my x value or my n value. Question?
I don't have a question.
Okay, question.
Would you add the n next to the 105? Or would that just...
I cannot combine the n and the 105 because they're not like terms.
No, I mean, like, because it said f of n and you put 105 and for f.
So we treat f of n, the whole thing f of n, like y. So we just replace all of f of n with 105.
Oh, I know.
What do I need to do here?
Would you subtract 55 to both sides?
Subtract 55 from both sides. What is 105 minus 55? 50. And raise your hand if you can tell me my last step to get n by itself. Someone who has an answer. You've answered today. Someone who has an answer today. I can wait here all day.
I think he's one center.
You've answered. You've answered today. My last step to get n by itself. Someone who has an answer today.
Divide 50 by 5.
Very good. Dividing both sides by 5. So what does n equal?
10.
So that'd be 10 total bits. Any questions on how we approach letter C?
No.
So letter A, we found our function, f of n equals 5n plus 55 for that specific arithmetic sequence. Letter B, we graphed the function over here. Here's our straight line. Letter C, it gave us the winning bid of $105, asked us to find how many bids would get us to $105. We found it using our formula, 10 total bids. You could have used Ryan's method, where you just kept the sequence going and going and going until you got to $105. You would look at the corresponding x value. Or, kind of the same thing, you could have kept your graph going up and up and up until you got to 105 on the y-axis. And look at that corresponding x value. You could have done it either way. I like using the formula, because especially if it's a huge number you're trying to find, they would have asked us to plug in 1,255,767. That'd be terrible to list that out that much. Right? So the equation is very, very nice to help us find the nth term of the sequence. Question?
Why would you not just divide it by 5?
Divide what by 5?
Divide by 5.
Do what?
Divide 105 by 5, and you just have your answer.
No, you wouldn't.
Whole thing?
Nope. Because my initial bid is $60, and it's increasing by 5 each time. 105 divided by 5 would give
Or
you...
not 5, 10.
21.
We did divide 5 by 10.
Hold on.
Or, no, we didn't. We divided 50 by 5 to get 10. What are you doing?
On my calculator.
So the formula helps us out a lot. Are there any questions about that? Yes?
Oh, sorry, I don't know.
Oh, you don't have a question? Okay. Are there any questions about the notes we just took?
No.
Here's our assignment.
So first hour, finished a little later than y'all. So I told them we're going to work on the assignment in class tomorrow. So that's what we're going to do in here as well.
Nice.
Okay? So, no homework tonight. Don't forget any of this stuff because, like I said, we'll be doing it in class tomorrow on the assignment.
Oh,
Are there any questions about the notes before I end my recording?